Suppose salinity of water to the depths 1,000. So latitude x is the depth in meters. Blah blah blah. Approximate the salinity when the depth is 795. So x is the depth, and here the depth is 795. So that means I'm going to just plug that into here. Who cares about what's going on, right? It's just basically find when I plug in 795, what do I get? Now, this is where a calculator is needed once again. So quit, get out of there, and it's 33.3 plus the log of 795 plus 1. So plus 1 is 796. So let's change that to 796 and 36.2. And I actually have an error here because I forgot to put the 1.4. So I'm going to go to second entry, go back right there, I remember it, go to second, insert, 1.4 times that equals 37.36. 37.3 to say nearest hundredth, 36. And that will be our answer. Two of those, okay. So let me delete this one. Solve this exponential equation. So here, do we have a common base? No, we don't. So what did we say back here? We said if you have a common base, that's good, or you have to take logs. Now once you take a log, these problems get easy super fast. So we take the log of both sides. Now, remember the power rule of logs is the log of m to the r power is r log of m. So I can bring out the exponent in front. So that's, I'm going to put parentheses around it because that's important that both of these get the log 4. So now at this point, this is just a linear equation. This is chapter 1 material. Log is just a number, so this is x is the highest degree we have here. But because there's a log, sometimes it looks a little scary, but it's actually just a linear equation. So we distribute the logs to this number all the way through, and we have x log 4 plus 4 log 4 equals 2x log 5 plus 5 log 5. We want to get the x's to one side. So we're going to move this over here, and then move this one over here. So we have x log 4 minus 2x log 5. Over here, this one's going to go over here, so that becomes minus 4. So I'm going to write this one first, because I don't like leading coefficients that are negative. Minus 4 log 4. So this is just the previous problem, except this has been moved over here, and the 4 log 4 has been moved over here. Factor the x. So here we have x, factors out, we're left with log 4 minus 2 log 5 equals 5 log 4. Now remember, this is just a number on this side. We could put this in our calculator at some point, but we're going to get round off error. So we try to keep everything in logs as long as we can. And our final answer is 5 log 5 minus 4 log 4 over log 4 minus 2 log 5. And it wants the answer in it wants the answer like that. Now the answer says natural log. It's going to give you the same answer. The ratios are still going to be the same. So log or natural log works the same either way. And you can try it if you don't believe me. The change of base formula shows that this will work. Solve this equation. Now, do we have a common base here? No, we don't. So we're going to have to take logs right away. So just the 4c. Actually, the answer sheet doesn't have it. Has just the answer. I'm going to do it both ways just to prove the point here. So over here, I'm going to take the log of 6, 3x equals log 8x plus 1. 3x comes out in front. And then this becomes x minus 1. Get, well, let's multiply this out. X log 8 plus log 8. Get this over here. We have 3x log 6 minus x log 8 equals log 8. Factor out an x. And divide. This is just a number, so we divide by it, and we have x equals log 8, 3 log 6 minus log 8. This we put in our calculator. Log 8 divided by parentheses 3 log 6 minus log 8, and close the parentheses. And we have negative, it wants rounded to nearest thousandth, so that's 6, 3, 1, 0. That always does this. Okay, so this is equal to 0.631. Now, to show the point that this is the same if you were to use natural log, we're just going to calculate it right here. So I'm going to just second entry. Actually, it'll probably be faster if I just type it from scratch. Natural log of 8 divided by 3 natural log of 6 minus natural log of... Now you have to be consistent. If you start using natural log, you got to use natural log all the way through. But voila, the same thing. Okay, solve this and in exact form. So the first thing we're going to do here is we would like to take a power, but the first thing we're going to do is condense it and then take the power. Condense and then take a power. So the first thing we're going to do is condense this. Now this is minus, so that tells us that that's the same as division, using the rule log m minus log n equals log m over n. So this is 3 plus x over x minus 4 equals log 2. Now what's the inverse of log? It's the 10th, the 10th power. So it's like I'm taking everything to the 10th power. This is going to cancel out, and I'm left with just 3 plus x over x minus 4. The 10 here would cancel out this log, and I'm left with just 2. So now we're left with just a chapter 1 problem. You can cross multiply, so we get 2 times x minus 4 equals 3 plus x. And we have 2x minus 8 equals 3 plus x. And subtract x, so we have x minus 8 equals 3. Move the 8 over, and we have 11 is our answer.